let's wait for maybe 1 more minute for your friends to come. Okay, in the meantime, I will share the questions yesterday. It's already 11 o'clock. I assume that all of your friends are here. So let me discuss this one. The yesterday questions, the review questions about the chemical bonding. Okay, in chemical bonding, this one. Let's start from this number. Number two, BF3 and then CH3OH is a reagent used to form methyl esters to form compounds containing acyl groups. In the diagram, X shaded dot and then also unshaded dot represent electrons from boron, fluorine, and oxygen. So boron has the X, and then shaded is the F, and then unshaded is oxygen. With tetrahedral structure illustrates the electron pairs around the boron atoms. We note that in boron trifluoride, the bond angle is 120. It does not have any lone pair. It has three bond pairs. The bond angle is 120 with the shape of trigonal planar. And then in CH3OH, there is there are two lone pairs in the oxygen, and there are two bond pairs in the O. One bond with CH3 and another one with hydrogen. So this one, and then there is because boron does not have any lone pair, so the oxygen will form a dative covalent bond to the boron. So the answer is B, and the electron from oxygen is unshaded circle. And then for next number, for next number, number 2 of the question, number 2, number 2, which element exists as discrete small molecules in the solid state? There are four options: aluminum, iodine, silicon, and sodium. Aluminum, silicon, and sodium, they are as can be included as metal, although some of them aluminum and silicon they are called as metalloid. Aluminum is transition metal, so three of them conduct electricity, although the conductivity is different because silicon is considered to be a metalloid, It is a semiconductor. Aluminium conduct electricity very well because it has three free electrons, while sodium has one free electrons only. And then iodine is the discrete small molecules. Discrete means separate from the others. And then next, number 3 of the question. Which of the following molecule is not planar? We learned already in benzene. Benzene has a hexagonal structure. It is a planar molecule. There is an overlap of the p orbitals. One we know p orbital is consisting of two loops. One loop on the top, one loop at the bottom. So the 6 carbon atoms in the ring forms an overlap. Looks like an overlap of the loops on top and below. So this is a planar molecule. And then boron trifluoride, we know boron trifluoride has bond angle of 120. It is trigonal planar. So it is a planar. And then ethene also there are 3 bond pairs and 0 lone pairs. So ethene has a trigonal planar with the bond angle 120. And then phosphorus trichloride has 5 electrons in the outermost shell of phosphorus and then 3 electrons occupied with the chlorine. So there is a free lone pair. There is a lone pair. The lone pair uh, makes the bond angle of phosphorus trichloride to be 107 with the shape of trigonal pyramidal. And then this one, number 5. Which of the following describes the change in the bond angle in water between ion when ion hydroxonium is formed? We know hydroxonium ion forms when water accepts proton. Water accepts proton because the water is acting as an alkali. This happens when water reacts with the acid. Okay, this happens when water reacts with the acid, and then in water molecule there are two lone pairs and two bond pairs. Two lone pairs and two bond pairs. The bond angle is 104.5 degrees with the V-shaped or bent. While in H3O positive ion, there are three bond pairs and one lone pair. So the bond angle is 107. From 104.5 become 107. There is a increase slightly. It is impossible to increase to approximately 120 because 120 has 3 bond pairs and no lone pairs. And then for the option A and option B, they are not the answer because the size of the bond angle not decreases but increases. And then now let's continue to next number. The next number, which set of property to a non-ionic compound which has a giant lattice. Giant lattice, we know in giant lattice structure, the giant lattice structure, it can also refer to giant molecular structure. Giant molecular structure like diamond and graphite and also Buckminster fullerene, they are solid at room temperature and pressure and they do not conduct electricity, although some of them there is an exception like graphite conduct electricity, but in general giant molecular structure does not conduct electricity. And then the melting and boiling point is very high, more than 1000 degrees Celsius. And then next number, ethanol is much more soluble in water than ethyl ethanoate. Uh, which statement helps to account for this? In option A, hydrogen bond forms between the hydrogen of the OH group in the ethanol and the hydrogen of water molecule. This option A is a incorrect statement. The correct statement of option A should be hydrogen bond forms between the oxygen of the OH group in the ethanol and the hydrogen of water molecule, or the opposite, hydrogen bond forms between the hydrogen of the OH group in ethanol and the oxygen of water molecule. And then B is the correct answer because hydrogen bond forms between the hydrogen of the OH group and the oxygen of water molecule. And then in option C, it is incorrect. Ethanol is polar and ethyl ethanoate is non-polar. The statement is correct, but the answer, the C, option C, does not explain and does not answer the question. It is a correct statement, but the statement does not answer the question because the question is asking what makes the ethanol to be soluble in water. Okay, ethanol soluble in water. Ethanol is polar. Okay, ethanol is polar, but the answer should explain why is it polar. I know some of you also do the similar respond when we had an offline class in the class when there was a question and some of you answered the answer. You made a statement, but the statement did not answer the question because uh, like in this question, the question is asking for solubility. Although the statement C is correct, but statement C does not answer the question. So if you answer a question, make sure you address your sentence to the question. Do not make a statement that does not answering the question. And then D, ethanol is able to dissociate into hydrogen ions and ethoxide ions, but ethyl ethanoate is not able to dissociate. This option D is correct statement also. Correct statement, ethanol is able to dissociate into hydrogen ions and ethoxide ion. It is correct. It is correct. But the problem, the statement D does not answer the question because statement D does not reflect how come ethanol is soluble. Also, so please remember, if you answer a question, answer according to what the question asks. Do not make a statement that does not answer the question. And then next, number 8. Number 8, what is the approximate value of the OCO bond angle? Okay, OCO bond angle, this one in ethanoic acid, this must be the functional group of the carboxylic acid. We know the structure of the carboxylic acid is RCOOH. It is R, C double bond O, and then OH. And then in the C as the central atom, there are 3 lone pairs and 0 lone pair. So the bond angle, in OCO, it is 120 degrees with the shape of trigonal planar. And then next, number 9. Number 9, a compound has the structure shown. What are the values of the bond angles X, Y, and Z? X here, the central atom is the carbon atom here. The carbon atom here, we know carbon atom has 4 electrons in the outermost shell. So the four electrons of the carbon atom, they are occupied with the other atoms. So in this one, the carbon atoms here in the central has two single covalent bond and one double covalent bond. So the bond angle in here is 120 degrees with the shape of trigonal planar. And then for the Y, the central atom is carbon atom, and then the carbon atom has 4 bond pairs. 4 bond pairs with 0 lone pair, it is a tetrahedral with bond angle 109.5 degrees. And then in last in Z, there is a C. This one in the set here, we know that there are 3 bond pairs and 0 lone pairs, so the bond angle is 120 with the shape of trigonal planar. And then number 10, a stable molecule containing atoms of elements X, Y, and Z has the following structure. Which element? X, Y, Z. B. Z must be an element uh, that requires 1 electron to make itself stable. Either it is sharing 1 electron to make itself stable for Z. And then for Y must contain 5 electrons in the outermost shell. 5 electrons in the outermost shell, and then because in the Y we know that this one will make 1, 2, 3, 4, and 5 electrons in the outermost shell, so it is a phosphorus. And then in the X there are 3 electrons in the outermost shell, so it is sharing 3 electrons in the outermost shell. So X must be a nitrogen. In here, it is a nitrogen, Y is phosphorus, and then Z is chlorine. And then number 11, the C2H2 molecule is linear. C2H2 molecule is a molecule with triple covalent bond. What can be deduced from this about the number of sigma and pi bonds present in the molecule? Because in this molecule there are triple covalent bond, and there are other 2 single covalent bonds. So the number of sigma bonds, there are 3 with and also there are 2 pi bonds. So this answer is D. Okay, this structure is called an alkyne. Last time when grade 10 we learned already about the alkene and also alkane. Next, number 12. The atoms X and Y have the atomic configurations shown below. So X is in group 2, and then while X is in group 2 and then Y is in group 6. X is metal elements, and then Y is non-metal. Y is non-metal, X is metal element. Which compound likely to form? It is XY, because X is forming 2 plus ion and Y forming Y 2 negative ion. So X and Y will become the formula of the compound. And then number 13, in which one of the following pairs do the molecules have similar shape? AlCl3 and BCl3. AlCl3 has 3 bond pairs and 0 lone pairs. BCl3 has 3 bond pairs and 0 lone pairs. So both of them have the similar shapes because both of them have the same bond angle. And then this one, and then this one next, AlCl3 and PCl3. AlCl3 has 3 bond pairs and 0 lone pairs. PCl3 has 3 bond pairs and 0 and 1 lone pair. So AlCl3 has bond angle of 120, while PCl3 has bond angle of 107 degrees. And then BF3 and NH3. BF3 has 3 bond pairs and 0 lone pairs, and then it has the bond angle of 120. In NH3 it has 3 bond pairs and 1 lone pairs, so the bond angle is 107. And then in carbon dioxide molecule, there are 2 bond pairs, and then in SO2 in CO2 there are 2 bond pairs with no lone pairs, so the bond angle is 180 degrees. In SO2 there are 2 bond pairs and 2 lone pairs, so the bond angle is 104. In SO2 there are 2 bond pairs and 1 lone pair. So in SO2 the bond angle is different from the bond angle in CO2. Okay, and then now before I continue, let me ask to Matthew Chandra. Hello Matthew. Hello Matthew.
Yes, teacher.
Okay. What is the bond angle? What is the bond angle of a molecule? Right now, of a molecule with 2 bond pairs and 1 lone pair. What is the bond angle of a molecule with 2 bond pairs and 1 lone pairs?
Two bond pair and 1 lone pair.
Yeah. The bond angle is
107.
no 119 with the shape bent. Okay, now let's continue. Number 14. Silicon carbide is a shiny, hard, chemically inert material with very high melting point. It can be used to sharpen knives and make crucibles. A giant structure, which type of the structure explains these properties? So the question is asking which type of structure explains these properties. So silicon carbide, shiny, hard, chemically inert material with very high melting point. Substance with very high melting point, it could be ionic compound, because it has giant ionic lattice structure, or this one has a structure of giant molecular structure. We know that if it is ionic compound, if ionic bonding, it is impossible. Why? Because in ionic bonding, it is not an inert material. Inert meaning does not react with any chemicals. So in silicon carbide, it must have giant molecular structure. We know giant molecular structure is a strong covalent bond. So in for number 14, this one strong covalent bond between the uh, silicon and carbon atom is the correct answer. It has giant structure containing metallic bonding. It is incorrect because metallic bonding is the force of attraction between positive metal ion and the negative uh, mobility of electrons. If option C, giant layer structure with covalent bonds between atoms, it is it is not forming layers. Okay, it is not forming layers, and if there is no forming layers, how can there be a van der Waals between the layers? And then D is simple molecular structure. It is incorrect because simple molecular structure would have the low melting point. And then number 15, new paints are being developed for cars to give them an effect similar to mother of pearl. These paints are based on small flakes of silica. So the silica, the formula of silica is silicon dioxide SiO2. In the structure of silicon dioxide, each silicon atom is bonded to X oxygen atom. X oxygen atom, X can be a number, can be any number, but must not be a decimal number. And then each oxygen is bonded to Y silicon atom because the formula is SiO2. Is the formula is SiO2. Therefore, each silicon is bonded to two oxygen atom, and then each uh, oxygen is bonded to this one is silicon bonded. Oh, sorry. Each silicon is bonded to four oxygen atoms. Okay, if we draw the structure of silicon dioxide, which you ever drawn the structure when you had your IGCSE chemistry, and then each oxygen atom is bonded to Y. The Y is 2 because there are four, so Si bonded to 4 oxygen, and then each oxygen bonded to 2 silicon, so the formula is Si2O4. In order to make the formula to be simple, so it is SiO2. Number 16. The atoms X and Y have the following atomic configurations. Atomic configurations, it is X, similar like the previous question. X is in group 2 metal, and then Y is non-metal with 4 or with 6 electron in the outermost shell. So the ion is X 2 plus and Y 2 minus. So the correct answer for this one is B. Okay, and then number 17. In number 17, number 17 until number 17, 18, 19, 20 until number This kind of question number 17 is very common and in every year for A-level papers, paper 12. Okay, only in chemistry subject A-level. So you have to write A if statement 1, 2, 3 are correct, and then B if statement 2 and statement 1 and 2 correct, and write C if statement 2 and 3 are correct, and then write D if only statement 1 is correct. Okay, in silicon carbide has the structure similar to that of diamond. Which of the following are predictable advantages of using a silicon carbide ceramic compared with steel? As we know, there's information already given the clue. Silicon carbide has the structure similar to diamond. So silicon carbide has high melting and boiling point. Because diamond has high melting and boiling point, so is silicon carbide. And then the second statement, silicon carbide is more resistant to oxidation, similar to diamond. Diamond also resistant to oxidation. Oxidation means in here cannot be combusted. And then silicon carbide is less likely to deform under compression. Similar to diamond, it cannot be deformed under compression as well. And then, so the answer for this question is statement 1, 2, and 3. And then number 18, which of the following contains hydrogen bonding? We know hydrogen bonding occurs when hydrogen bonded to very electronegative elements such as nitrogen, oxygen, and fluorine. In statement number 1, the hydrogen is hydrogen. The hydrogen here has uh, N has bonded to N here, and then there is a Cl. In NH4 itself, there is a hydrogen. This is called as polyatomic ion. But in NH4Cl, this one is an ionic. In hydrogen bonding means the intermolecular forces, the molecule must be having a covalent bond. So the molecule are NH3 and nitric acid. Nitric acid, it is covalent compound, covalent molecule, and NH3 also covalent molecule. While NH4Cl is an ionic compound. Okay, and then next number, this one with the ease with which fabrics become stained depends upon the nature of the fiber used. Carpets made from wool, which is a protein, and are relatively easily stained, whereas floor coverings made from polypropylene are more stain resistant. Which correct statements explain why wool is easily stained and polypropylene is not? The question is asking the explanation why wool is easily stained. Okay, look at the statements. It is number 1. Wool contains side chain hydroxy groups. It is correct. Why is it correct? Because hydroxy groups means it contains OH. Contains OH means the intermolecular force is hydrogen bonding. If the intermolecular force hydrogen bonding, so this will absorb able to absorb the stain, because stain are made up of polar molecules. So, because hydroxy is there is electronegativity difference, so become polar. So statement 2 is also correct. And then statement 3, polypropylene is a saturated hydrocarbon. It is a correct statement. Statement 3 is correct, but the statement does not explain why wool is easily stained. This is when you make a statement, make sure your statement answers the question. Okay, like in this one, polypropylene is saturated hydrocarbon is correct, but the saturation does not explain why it is stain resistant. There is no relation between saturation and stain resistant. Next question, number 22. Number 22 here, in the gas phase, in the gas phase, this one, okay, in the gas phase, uh, aluminum chloride is a dimer of Al2Cl6. By using this information, which of the following are structural features of Al2Cl6 molecule? The features is this one. The feature is only number 1. Each aluminum atom is surrounded by 4 rhodium atoms. There is a dative covalent bond in the structure of Al2Cl6. Please open your textbook or search in Google the structure of Al2Cl6. And then there are no 12 non-bonded electrons. So here it written non-bonded electron pairs. So it is incorrect. And then number 3, each aluminum atom contributes electrons to 4 covalent bond is also incorrect, because aluminum can have only 3 electrons to make itself become a covalent structure. Number 23. Number 23, which particles have a single unpaired electrons? Of course, it is in copper, because copper is in D block, and then in metal free radical, there is unpaired electrons, and then there is also in molecule of nitrogen monoxide. You can refer to the textbook or you can refer to the Google. There is the diagram already. Okay, you just need to make the structure and tell from the structure. Okay, next, number 24, how many sigma and pi bonds are present in the structure of HCN? We know in HCN the central atom is the carbon atom. In the carbon atom there is one single covalent bond with hydrogen, and there is one single covalent bond with nitrogen, and a double covalent bond with nitrogen. So in here, the sigma bond there are 2, and then the pi bond also there are 2. And then next, number 25, which type of intramolecular forces present in barium chloride? the intramolecular forces in barium chloride is ionic bonding. Okay, it is ionic bonding because barium is pure metal and chlorine is non-metal. And then next in this one, the last is boron trifluoride polar or non-polar. It is non-polar. We ever have this kind of question during the discussion of the questions chemical bondings in simple molecules. Okay, so this is the discussion of the uh, question for the review tests. From here, is there any question?
Teacher,
Yes.
I think there's one question missing.
One question missing.
Yes, because yesterday we had a question asking about the options were sodium chloride, sodium, and iodine.
Sodium, iodine, and sodium.
Sodium, iodine, and sodium chloride.
Let me see here. This one. I did not change the question. Is this what you meant, Natasha? Hello.
Can't see. I don't. It's not on the screen.
It's not on the screen. I'm sharing the screen. I'm sharing the screen. I don't have any problem with my internet connection, Natasha. Um, Bavia, hello.
Yes,
Okay,
teacher.
now I
Can
can see
you
it.
can you see the question that I shared on the screen?
Yes, teacher.
Yes. So if Bhavya can see the screen, Natasha, maybe you need to refresh.
Now I can see it, teacher.
Okay. There is this question, Natasha. Is this what you meant? The solid have giant lattices. It is there is an iodine and then sodium and sodium iodide. Which one has giant lattices? It must be sodium and sodium iodide because because sodium is a metal and then sodium iodide is an ionic compound. Ionic compound will form giant ionic lattice structure. Giant ionic lattice structure, yes. Sodium will form metallic structure, metallic lattice structure. Then iodine will form a simple molecular structure. Okay.
Thank you,
From
teacher.
from here, from here, sorry, from this one, from this one, from this one, I can see there are 21 students give respond. In here, there are 22. 22, 1, 2, 3, 4, 5, 6, 16. Okay, so there are 21. So all students, I consider they are already here. Okay, so there is the latest one. There is Sharon Jessica. So I can check here based on the questions here how many students give the correct respondents and then how many mistakes. So at least for uh, question with the number 8 has the least this one has the least correct, and also this one number 9 this one number 9 is number 9 only 10% of the respondent correct answer. Now let's see what is number 9. So from here we are able to tell in which one all of you have the uh, lack the lack in which number. Okay, number 9. Let's see in number 9. Okay, number 9 in this one. So many of you made mistake in number 9. Am I right? Natasha, then I do not know who are they, but only says here 10% correct answer, while the 90% incorrect. That's what it means by this result. Hello?
Teacher, to solve that question, so we should look at the number of bonding.
Yeah, you should look at the central atom and then number. That's why I like to use test using this one, because I can see which one is the weakness. So the most weakness is in number 9. For the other numbers is around 50% above. 50% above meaning almost more than half class could answer. And then the second is this one, number 22. Number 22, number 20.